Hiya, Mrs. McTaggart here. So in this video, I'm going to work through a practice paper. Now this is a practice paper that isn't available online anywhere else. It came in a random book that I had, and I've selected questions that I thought would be good for Easter study. And if we were doing this in the classroom, this is what I'd be giving out for everyone to work through, because it would be something nice and new for everyone to see. So on the video, how you do this is up to you. You can print off the PDF copy that you'll get sent if you're one of my pupils. If not, you could just do it solely from the video and pause each time I change my slide. Pause, try it, and then watch my solution, see what you'll get. I'll also try and show you where the marks would be, so you can have a rough idea of marking it for yourself as well. So we'll have a paper 1 and we'll have a paper 2. So let's have a wee look at the paper 1 first of all. So this is the non-calculator questions, okay? Okay, this question, we have a straight line and it has this given equation here. We are asked to find the gradient and the point where it crosses the y-axis. That's a fancy way of saying y-intercept. The problem is you cannot read off the equation of that line unless it is in the form y equals mx plus c. So that is our aim. So our first mark would be for changing the subject to the formula here. So for me, that plus 2x in the wrong place, so I'm going to bring that to the other side, and I'm going to put that first because I always like the x before the number. So I've got negative 2x plus 4 equals 1/2 y. Then we need to deal with a half. The opposite of halving is doubling, so we're going to times everything on the other side by 2. So that becomes minus 4x plus 8 equals y. So that means that our gradient is whatever is in front of the x. So our gradient is minus 4. And our y-intercept as a coordinate would be 0, positive 8. And your marks, if you were marking this, there would be a mark for rearranging into y equals. It doesn't matter if my y is on the right. It could just as well be like this over on that side as well. There would be a mark for your gradient and there would be a mark for your y-intercept, preferably as a coordinate, please. Okay. Question 2, bread and butter question. We love these. Expand and simplify. So the method is we times everything in the bracket first of all by x. So that gives us x cubed plus 2x squared minus 9x. Okay. Then we're going to times everything by negative 10. And beware, it's a negative 10, so all your signs will change. And a wee tip here is when I do this, I don't do it as one big long line with 6 terms. I kind of line it up. So minus 10x squared, I put below my other x squared. Then I would have minus 10 times 2 is minus 20x. And then a minus times a minus gives you plus 90. And it just lines up really nicely that you can then tidy up a wee bit easier. So you've got x cubed. The x squareds give you 2 take away 10 is minus 8. Please be careful with these. This is where people make the mistakes. It's a simple integer questions. Negative 9, negative 20 is negative 29x plus 90. And if we were marking this, we would give you a mark for the first 3, a mark for the second 3, and a mark for tidying it up. And when you tidy it up, there must be an x cubed bit in it, otherwise you'll lose another wee mark. So that's that one. Okay, for this question, normally we'd encourage you to do the bit in the brackets first and then multiply by the 3/5, but it is possible to multiply out by the 3/5 and then do the subtraction. We have seen that done in a past paper before, but I'm going to follow rules of BODMAS and do the bit in the middle first. So my first sum is going to be 5/6, take away 2/9. Now you could turn these all both into something over 18, which is the lowest common multiple, but for the sake of my pupils, I just teach smile and kiss. So the kiss part is turning your denominators into 6 times 9, which is 54. So you've got 2 fractions both over 54. Then you start at the top left and you do 5 times 9 is 45. You do 2 times 6 is 12, so you're left with 45 take away 12, which is 33 over 54. Now 33 and 54 will simplify there, both in your 3 times table, which will give you 11 over 18. So now we're going to do the multiplication. We're going to do 3/5 times 11 over 18. Now if you're happy with the cross cancelling, we're going to cancel out the 3 and the 18, And that leaves us with 1 and 6. And then when you multiply, on the top you have 1 times 11, which is 11, and the bottom you have 5 times 6, which is 30. If you're not comfortable with cross cancelling, just do 3 times 11 is 33. 5 times 18 is 90, and then you can simplify that down. The final answer is 11 over 30. Okay, so on this one we have a vector pathway question. We're told that these are identical squares and we're told what the vectors m and n are. So they're the ones we've got to follow when we're doing our journey. So we're trying to go from x to y. So x to y is simply down here, which is the opposite direction of m. So x to y is negative m, and then we'd travel along n, so it would be that. Remember, you could write that as n minus m if you want. Either of them would be okay. Then it wants us to work out the pathway for A to D. So to go from A to D, I would be travelling along N. So A to D would be along N. And then I would just go directly up to D. And because we know these are identical, then that is parallel to vector M. So I'd be going the same direction as M, which is N plus M, or M plus N. I really don't mind which way round it goes. Nice easy 1 mark each question there. Okay, number 5, we've got a function question, and we're told g of x is given by this thing here, and we have to work out g of 4. So g of 4 is simply replacing x with a 4. So we've got the square root of 4 plus 1 over 4, which gives you 2 plus 1 quarter, and you can leave that as 2 and 1 quarter, or you can make it top heavy and say 9 over 4. I really don't mind which one. So on this question, there would be a mark for obviously an answer, and there would be a mark for substituting in there correctly. Okay, nice and easy. Question 6, equation of a straight line, but it's from a scatter graph. So a scatter graph is showing the relationship between the temperature on the farm and the weight of the farmer's harvest in tonnes. So there's a wee misprint here, that should not say kilograms, that should say tonnes, because everything else is in tonnes. So it says point A represents a temperature of 10 and a harvest of 77. There's your first coordinate. So point A is 1077. And then point B represents a temperature of 24 and a harvest of 35. So we're going to get our gradient. So our gradient is y2 minus y1. So I'm going to go with the big numbers first. So I'm going to do this 77 take away 35. All over, subtract your x's. So that would be 10 take away 24. 77 take away 35 is 42. Over negative 14. 7 times table in there, so that would be, in fact, see if it's 14 times table, that gives you negative 3. So our gradient is negative 3. We don't have a y-intercept, so we're going to use the y minus b equation. So we're going to use y minus b equals m bracket x minus a. I'm going to use the 24 and 35 just because they're smaller numbers. So I'm going to have y take away 35 equals negative 3 bracket x take away 24. If I multiply this out, I've got negative 3x plus 3 times 24 is 72, and then that plus 35 will come over. So I've got y equals negative 3x plus 107. But I'm not finished because the question wants it in terms of t and h. So your y-axis has become h for harvest, x has become t for temperature. So this is our formula. Part B wants us to use a temperature of 20 to work out the harvest. We replace t with 20. So I'm just going to go straight to negative 60 here if that's okay. Because 3 times 20 is 60, but there's a negative. So negative 60 plus 107 leaves you with an answer of 47 tonnes. In terms of the marking for this one, now for the equation, you get a mark for the gradient, you get a mark for substituting into your line or for finding C if you use the other method, and you get a mark for your final equation. Now if your equation is not in the form h and t, you won't get it. So if you leave your answer like this, you don't get that third mark. And then the last bit is just 1 mark for substituting in and finding the answer. Okay, then we've got a wee third question. So for this one, we have to be aware of a couple of rules about surds. Now the first rule is knowing that anything to the square root is a power of half. So we've got n to the power of 5 times n to the half all over n to the 3/2. And if you don't know that, you're not going to be able to pick up full marks here. So I'm going to do the top line first of all. So you're multiplying, so you add the powers. So 5 plus a half. If you're not sure, turn that into a top heavy fraction. 5 times 2 is 10 plus 1 is 11. So that would be 11 over 2. So I've got n to the power 11 over 2 all over n to the power 3 over 2. Now we're dividing, so we subtract the powers. 11 halves take away 3 halves is 8 halves. Oops, 8 halves. And 8 halves is the equivalent of 4. Okay, so 2 marks here. 1 for your final answer of n to the power 4 and 1 for calculating that n to the power 11 over 2. Now there is another way. The other method is by dealing with the halves first and cancelling down the halves and leaving you with n5 times n to the power, a half take away 3 halves gives you -1. And then that gives you n to the 4 as well. But I don't think that's the most obvious way to go about this one. Okay, next we have a change the subject of a formula, 3 marks. This isn't one of the nicer ones that we usually see though. So our aim, remember, is to get v on its own. So the first thing I'm going to deal with is I'm going to deal with that half. I'm not going to multiply the bracket because that would just give me fractions everywhere. The opposite of halving is doubling, so we multiply that side by 2 and you're left with 2w and then m times your bracket. Again, you could multiply out your bracket here, but that's just going to introduce more m terms. M is multiplying the bracket, so I'm going to do the opposite of multiplying, I'm going to divide. So I'm going to do 2w all over m equals v squared minus u squared. From there, we need to take the u squared over, so that's going to join the fraction but not become part of it. So it'll become plus u squared equals v squared. And then the opposite of squaring is square rooting, so you need to make sure a big square root goes over everything on this side. So that is your answer there. Now it says this is worth 3 marks. Now this is a wee bit of a cruel question because I had 4 steps there. So there would definitely be a mark there. There would be a mark possibly for, there would be a mark for moving over the u squared. And I think what they're hoping is that you do this in one go. So some people might go straight to the 2w over m stage in one go. So that's where the 3 marks would be there. But generally you would not have 4 operations or 4 things to move like we had to do there. Now we bring ourselves to a missing angle one. Always read the wee bit up here because the minute they tell you about a tangent, it means you've got right angles wherever your radius meets that line. So I talk about a wheel sitting on the ground. That's where your tangents are. So down here we've got 2 right angles. Now we're also told about parallel lines, so that means we've got some Z shapes going on, okay? So because these 2 lines here are parallel, the first thing I can think of putting in is that that's a 40 in there. Now I've not even read what we're after. Sorry, we're after angle DTU. So it's this wee shaded angle down here we're after. Okay, right, where do I go next? Right, we've got a radius and a radius here. So this is isosceles, so that's 40. 40 is 80, this is 100, that's also 40. We've got another Z shape going on here. If I just draw this in with my red pen, there is a Z shape there, okay. So that means that this one up here is 40. And also C to T is a diameter, so CDT is a right angle triangle within a semicircle. So there's a right angle here as well. I normally look for them first. And then that makes the angle down here at T. 90 plus 40 is 130. Away from 180 makes this 150. And then that means that my missing angle, so DTU, is 90 take away 50, which is 40 degrees. So there's a lot of 40s going on in that one. Okay, our next question is a slight spin on your discriminant question. They have given you the equation with the value of c and they have said use the discriminant to find the value of c. Now normally they would say find the value of c when it has equal roots or 2 real roots, but this time it doesn't say it, but you have to recognise it from the picture. So looking at the picture here, because this is sitting on the x-axis, that means it's got one real root repeated. So that means you get to put b squared minus 4ac equal to 0, okay? So you take that from the picture, and you would have been taught that your first ever lesson on discriminant. So that's what we're doing. So a is the number 1, b is the number minus 6, and c is just left as c. So b squared is negative 6 squared, so that's just going to go to 36. Take away 4 times 1 times c. So you've then got 36, take away 4c is 0. That gives you 4c is 36, whichever way you rearrange this. So c is the number 9. And that's the answer to that one. So it's not that bad, it's just a different wee spin on the start for it. Now, I didn't mention where the marking would be for this one. So the marking would be first mark for knowing to put your discriminant equal to 0. Second mark for substituting incorrectly. And third mark for getting your value for c. Okay, so this is a 2-mark trig identity question. So before I do it, I'm just going to write out all your trig identities because I think we might be using some of them here. We know that tan x is sin x over cos x. And then that would be the same for tan squared and sin squared, etc. We should remember that sin squared x plus cos squared x is equal to 1. Okay, and from there you can see that sin squared x is 1 minus cos squared, and you can see that cos squared x is 1 minus sin squared. So what we have is, I'm going to replace that tan squared with sin over cos. So we have 1 plus sin squared x over cos squared x. Okay, so that would get you your first mark. Where we have to go from there is, you'll notice that this 1 over cos squared x is just a single fraction. So we need to turn this into a single fraction. So I'm going to turn that into 1 over 1. Now you have an option depending on what you've been taught. I can now do smile and kiss, or I can write the 1 over 1 as cos squared over cos squared. Either way, if I'm doing smile and kiss, that would give me cos squared x plus sin squared x all over cos squared x. And then we know from the rules over here, there's sin squared plus cos squared. I know I've got it the other way around, but it's the same thing. So that makes the top line 1 over cos squared x. And that would be your second mark there. Okay, so I've done this question a few times and I don't like it. It's a wee bit nasty. What we've essentially got here is, if I draw them out again, you've got your small one with 9 over root 6 as your length, and you've got the big one with 2 root 6 as your length. And your area of the big one is 160. To get this area of this 6-sided shape, we're going to have to find this area and then take them away. Now, the issue is, when I go to do my scale factor, I'm going to have fractions over fractions, and I've looked at it, different ways of doing it, and there is no nice way. So, scale factor will be, it helps if I'm using my pen. So my scale factor will be 9 over root 6 all over 2 root 6. Now that doesn't look very nice, does it? So I'm going to rewrite that as 9 roots, oh sorry, that's wrong as well, oh my goodness. So I'm going to write that as 9 over root 6 divided by 2 root 6 all over 1. Then I am going to flip that, keep it, change it, flip it. So that's going to be 9 over root 6 times 1 over 2 root 6. And that will give me 9 over root 6 times root 6 is just 6 with a 2 in front, which will be 9 over 12. And 9 over 12, we all know, simplifies down to 3/4. So my little area will be my scale factor squared, because it's an area question, times the big area. Now, if you square all this, you will get 9 over 16 times 160. Those 16s will cancel out and you're just left with 9 times 10, which is 90. So the small area is 9 centimetres squared. So the 6-sided area that they want, so the area for this shape PQRCBA is your 160 for the big one, take away 90 for the small one, leaving you with an area of 70 square centimetres. So nasty bit of surd work there for that one. Okay, I'm sorry about that. Now let's have a think where the marking would be. This would be a 4-mark question. So There's definitely a mark for our final answer. There's a mark for getting the 90 centimetres. There's a mark for probably getting your scale factor is 3/4, and there will definitely be a mark for knowing to square your area scale factor. I feel that was an awful lot of marks to go for your scale factor, but then again, if you couldn't get the scale factor but could do all the rest with the wrong thing, you would have still picked up some marks there. Just a nasty wee bit of surd mark there. So that brings us to the end of paper 1. We are now going to look at the paper 2, where we are now allowed a calculator. So question 1, straight in with another straight line question. Now, I know that's a bit strange because there was a straight line question in the other one, and that would never normally happen. You would probably only have one equation of a straight line question, whereas this paper has had 3. It's had one where it wanted you to find the gradient, and then it had one with a scatter graph, and then this one. So you would generally only have one like this or one like the scatter graph. So equation of a line, you need to get your 2 coordinates, you need to get your gradient. So your gradient will be subtract your y's, so you'll have 8 take away 2 on the top, 5 take away 3 on the bottom, which will be 6/2, which is just 3. So my gradient is 3. We don't have a c value. Now some people are taught to substitute into y equals mx plus c to get the c value. I don't do that. I use the y minus b equation. That's what we teach, so that's what I'm going to use here. And you can choose any of your coordinates. I'm just going to go with the one with the 3 and the 2. So we've got y take away 2 equals 3 bracket x minus 3. Y take away 2 is 3x minus 9. And then bring that over, you've got y equals 3x minus 9 plus 2 takes you to minus 7. Okay, and that's a 3-mark question, kind of standard. One for your gradient, one for substituting incorrectly, and one for rearranging and finding out that your c is minus 7. Our next question is a little inequality. So first thing we're going to break that bracket. So you've got 7 plus 3x minus 6 is less than x minus 11. I'm just going to tidy up the left-hand side. 7 take away 6 is 1. So you've got 1 plus 3x on the left is less than x minus 11 on the right. I'm going to bring the letters to the left. So I've got 3x take away x is less than negative 11. Don't forget that minus was there. Take away 1. So you've got 2x is less than negative 12. There's no having to worry about flipping the signs here or anything because your x is positive. So we're simply dividing by 2. So you've got x is less than minus 6. So a really nice one there for 3 marks. A mark for getting to there. A mark for probably multiplying out your bracket. And a mark for getting to the 2x there. Okay, then we have another non-calculator question again. Fully factorise. Fully factorise, and the 2 marks tell you that there's more than one step to it. Obviously, you should spot the common factor of 7. So you divide everything by 7, and that leaves you with t squared minus 9. Now that is not worth 2 marks, okay? So that t squared minus 9 can go further. You should notice that that is a difference of 2 squares. T and t give you t squared. 3 and 3 give you minus 9. 1 with a plus, 1 with a minus. And in that one, you would get a mark for common factor and a mark for difference of 2 squares correctly. Okay, please don't go straight to that final line. Put that line in between, make sure you get marks. You don't want to be going straight to an answer and getting it wrong and then you get nothing. Okay, question 4. We're going to need a calculator now for this one. It's a triangle, so it's obviously some kind of triangle trig. It tells us the area, so I know that it's going to be area equals half AB sine C. And luckily, they've actually kept it in the right order. We've got our AB sine C here. But they've told us the area is 18, so we have 18 equals a half times, now your A is that, we want the side AB, so we want the little b, we don't know that. So we know it's a half times 7 times b times sine 24. Okay, now from there's 2 different ways to go. We could do completely changing the subject, or we could just do a half of 7 times sine 24. A half of 7 times sine 24 is 1.42 something. So I've got 18 equals 1.423 and so on times b. And then b will be 18 divided by that number. So 18 over the number. Now I'm keeping that full thing in my calculator. And I'm just going to do 18 divided by my answer button. And it gives me 12.644. But they want it to 3 significant figures. So that would be the 12 and the 6 are staying. So 12.6 centimetres to 3 sig fig. Okay, so as I said, yeah, at this point you could have done change of subject. You could have done 2 times 18 is 36, 36 divided by 7 and divided by sine 24. I prefer to just kind of work out what I can on the right hand side first. So marking for this one, the final mark must include the significant figures. There would be a mark for your substitution into the area formula, and there would be a mark for maybe rearranging to work out what B was. So possibly this kind of line here, knowing how to get B. Okay, question 5 is a percentage question. It's a bit of a twist because they've actually done the 2 different styles of percentage questions in the one question as part A and part B. Now, I didn't like the wording of this question. So, this is upon about a delivery company want to increase the number of daily deliveries by 5% each month for 6 months. Please don't go into thinking, right, well, that's 30 days a month, 6 months is 180. It's not that, right? We're just going to say, well, this month they had 30, so it says our original amount is 33. So in month 1, it was 33 deliveries. In month 2, they want that to go up by 5%. In month 3, they want that to go up by 5% again. So it's going up by 5%. So 100 plus 5 is 105%. As a decimal, that is 1.05. We are doing it for 6 months, so we're going to do the power 6, and it's times 33. And if you type that into your calculator, you should get 44.23. Now, they've not mentioned rounding. Now, in my common sense would probably be to round to the nearest whole number and say the number of daily deliveries after 6 months will be 44. But if you're not sure, you're always safe leaving it as 1 or 2 decimal places. I don't think that looks very much like the word deliveries, but there you go. So that's part A. Part B, it says another company has increased its daily deliveries by 15% and they now make 46. What did they previously make? So that's your reverse percentages one. So if they've increased it by 15%, that is the equivalent of 115%. So their 46 deliveries are 115%. Our goal is to work out 1% and then 100%. So it's here kind of ratio one. So we're going to divide that by 115 and then we're going to times our answer by 100. So 46 divided by 115 is 0.4. Times that by 100 is 40. Now what I like about those questions is you can always double check your answer back. Work out 15% of 40. Well, 10% is 4, half of that is 2, 4 and 2 is 6. It had increased by 6. So you can always check those ones back. So marking for this one, you get a mark for doing the 1.05, you get a mark for the power 6, and you get a mark for your answer for part A. On part B, you get a mark for this first line statement, you get a line for your second line, and you get a mark for your third line. Okay, percentages are usually done really, really well, so it's good if you can do those ones. Okay, next up, we have our simultaneous equations. Again, I'm not too keen on the wording for this one. But anyway, we've basically got a train that makes 6 trips between the city and the beach. So we're doing 6 trips to the beach. So I'm going to underline the key information. So we've got 6 trips to the beach and 7 trips to the city. No, we don't. To the lake. This is what I did with this one the first time I did this question. So there's the key information. So we've got 6 trips to the beach, 6 trips to the lake, and it takes 201 minutes. So we've got 6 beach plus 7 lake equals 201. Okay, let's look at our second equation. So our second equation, the key information is 2 beach and 3 city. So we've got 2 beach, I keep saying city, it's 3 lake equals 75 minutes. So I think the fact that we're talking about beach, lake and city threw me because there was an extra kind of thing in there. Right, so I'm going to move all this up. Part C says, how long does the journey take? So there's your first 2 marks for getting your 2 statements, okay? So there's marks 1 and 2. Then we need to get them into equations where like either the first 2 or the second 2 terms are equal. Oh God, in this one it would definitely be easier to get the beach ones equal and just times the bottom one through by -3. But I know if my pupils are watching this, they're in the frame of mind where they always go with the middle letter. So be aware you could just times the bottom one through by -3 and eliminate the b's. But I'm going to stick with my guns and go with the middle one. So I'm going to times the top one by 3 and the bottom one by -7. And then that way the middles will both turn into -21. So we have 18b plus 21l equals 603. And on the bottom we will have -14b minus 21l, and please don't do this in your head. If you're not sure, go to your calculator. It is a calculated paper, and that will be -525. And then when we add those two together now, 18 taken by 14 is 4b, and 603 taken by 525 is 78. And then 4 into 78 would be 19.5. Now, normally I would think, oh, wait a minute, it's a decimal, but we are talking about how long a journey takes, so that's possible. So beach journey is 19.5. Now I'm going to put that back into probably my second equation just because it's lower numbers. So I've got 2 times 19.5 plus 3l equals 75. Double of 19.5 is 39. So now 39 plus 3l equals 75. So 3l equals, now if you subtract them, you get, now I'm using my calculator for all this because I don't want to make mistakes. It's 36, which divides nicely by 3, so this is looking good. So it looks like L is 12. Okay, I'm going to double check my answer. So with my calculator, I'm going to substitute back into the top equation. I'm checking that 6 times 19.5 plus 7 times 12 should come out as 201, which it does. So I've just done a wee check in my calculator using the equation I didn't use to check that they are the right answers. They work for both equations. The last thing to do is conclude your question. So a beach journey is 19.5 minutes. And a lake journey is 12 minutes. If you don't conclude a wordy simultaneous equation question in words, you don't get that last mark. So the marks here would be for your conclusion in words, your L, your B, and for getting them both with a common number either at the front or in the middle. Okay? Okay, next we have a scientific notation question. This would normally come a bit earlier on in a paper. So we're told the weight of a grain of sand, this teeny tiny number. We're told a section of the beach is cleared and the total weight of sand is this number. We have to use this information to estimate the number of grains of sand. So what we have is we have the grains of sand. So we've got the number of sand times the weight gives us 134. So to get the number of grains, we're going to have to divide by the scientific notation bit. And it's really hard because most people know it's a divide, but we get confused and think, oh, which ones do I divide by? So that's why I wrote it out like this, which isn't necessary, but it helps get my head around it because this 134 is the total weight, this is the weight of 1, and to get the total weight, I would have multiplied the two together. So the number of sand would be 134 divided by 6.7 times 10 to the negative 4. Now, on your calculator, you should have a button that says times 10 to the x or a button that says exp. That does the whole times 10 to the power bit. So I'm literally typing in 134 divided by 6.7. I'm pressing that button and I'm typing in negative 4. And the calculator gives me 2 with 5 zeros. The alternative is you could think of that as 134 divided by 0.12367 and actually put the number back into full and do it that way. That'll give you the same answer. Now I'm just going to check the question. It wants an answer back into scientific notation. So this will be 2 times 10 to the power 5 numbers after the 2, so it'll be that. So that is the number of grains of sand. Now your marking scheme for this one, it's only worth 2 marks. There would be 1 for your final answer in scientific notation and there would have been 1 for that known to divide. So people who leave their answer as 200,000, you lose your second mark. So be careful, always check the question. Question 8, we have a magnitude question, and it's a nice straightforward one. So the magnitude of h is when you do the square root and you take each of your numbers and square them and add them. So 55 squared, add 20 squared, add minus 1 squared. And you literally go straight to your calculator now. A wee tip, don't put that negative in. Just type in 55 squared plus 20 squared plus 1 squared, because you should know at National 5 that minus 1 squared is going to be positive anyway. So 55 squared plus 20 squared plus 1 squared is 3426. So we've got the square root of 3426, and they wanted to 3 significant figures, which is, I'm just going to write it out first to help you with the rounding. It gives us this, and it goes on and on and on. To 3 sig fig means we're keeping the 5, the 8 and the 5. That 3 is not going to do anything. So there is your answer to 3 sig fig. Now, there's only 2 marks in this one for your final answer and one for the substitution in there. Actually, you'd get that one for knowing how to find the magnitude. Okay, fractions. So this is a divide and a fraction. So the first thing we're going to do, or there's different ways to do this one, is we're going to keep it, change it, flip it. So we're going to keep the first fraction. Although something's jumping out at me, I'm itching to take out a common factor there on the top line. We're going to turn that into a times, and we're going to make that 9q over 5p. So as I said, I've instantly spotted a common factor on the top left here of 5p. So I've got 5p bracket, 4p minus 1, all over q squared, times 9q all over 5p. Right, we're going to start cancelling diagonally. 5p and 5p will cancel out. A q will cancel there with the q squared, leaving you with a q. So your final answer will be your bracket times 9. I'm going to do it over here. So you've got 9 times your bracket. And on the bottom, we've simply got a q. So there is your final answer for that one. Now, 3 marks, okay? 1 for just being able to know that you keep it, change it, flip it. 1 obviously for your final answer. And I'm reckoning the 3rd mark will be for factorising the 20p squared minus 5p. So that is a wee change on your fraction question. It's got factorising and fractions. And actually they did one very similar to that a few years ago, so they're starting to get a wee bit clever. Okay, so straight off, this is a trig equation. Easy way to recognise it is by this bit here. So this is when we're going to use our all sine tan cos. Our first goal is to rearrange this so that it's sin x equals. So what I'm going to do is I'm going to move the 12 to the other side. So I've got 3 take away 7 equals 12 sin x. So I like my sin x to be positive. 3 take away 7 is minus 4. So I've got minus 4 equals 12 sin x. So I'm going to do minus 4 divided by 12. I'm just going to switch it round if that's okay, because I like the sin x on the other side. So it's minus 4 over 12, which we know is minus 1/3. You can leave it as a 4 over 12, though, that would be fine. Right, from there, because sine is negative, we don't tick all in sine, we tick tan and cos. Okay, so once we get our acute angle from the calculator, we're going to apply it to tan in the cos box. So at this point, you do shift sine of 1/3. You do not put the negative into the calculator. So an acute angle, and I'm just going to put it in to show you what I'm doing the inverse or shift sine of 1/3. Because the negative is just to help you decide those boxes, okay? So shift sine of 1/3 gives us the nearest whole number is 19. So my acute angle is 19. So the angle for x in the tan box is 180 plus 19, which is 199. And in the cos box, it's 360. Take away 19, which is 341. So our answers are 99 and 341. And I'm underlining them so that the person marking knows that they're the final answers and not this 19, okay? If you wanted to, you could then conclude it and say it's 199 and 341 degrees and write it that way. So there would be a mark for getting your 2 answers. A mark for getting down to the fraction part of sin x, and a mark for, well, there'll be a mark for your 2 answers, sorry, so there'll be a mark for both of them. Okay, we have a semi-interquartile range question. So the first thing I've noticed is these aren't in order, so I'm going to pause and put these into order. Okay, so that's my numbers in order. So to get the median and semi-interquartile range, we need to find the middle. Middle of 10 numbers means you've got 5 on each side. So there is my middle, and there is the middle again. So my Q1 is 349. My Q2, which is my median, is between 394 and 398, so 396. And then my Q3 is 589. And the semi-interquartile range does exactly what it says in the tin. Semi means half. Range is highest, take away lowest. So it's Q3 minus Q1 all over 2, which is 589 minus 349 all over 2. And when you work that out, excuse me while I go to my calculator, 589, you get 120. Okay, so the semi-interquartile range is 120. That's worth 3 marks. So what you do here is on this one, you get a mark for your median and you get a mark for both your quartiles. So they kind of share a mark, and then there's a mark for semi-interquartile range. Then we've got part B. Now part B is very similar to your statement in a standard deviation question. The bigger the semi-interquartile range, the more spread out the numbers are. Same with standard deviation. So what we've got is the first lot of information. I didn't even read what it was about. It was about a band performing in 10 different locations and their ticket sales. The second bit was about a solo artist. Now the solo artist had a median of 567, which was a lot higher than our median of 396. And they had a semi-interquartile range of 234, which was a lot higher than ours of 120. So we have to make 2 valid comparisons about the ticket sales of the band and the solo artist. So because the solo artist came second, I'm going to talk about that. So I'm going to say, because the median is higher, the median is a type of average, remember? So I'm going to say, on average, the solo artist sold more tickets. Okay, so on average, the solo artist sold more tickets. And that's because she's got a higher median, sold more tickets. And that's because of the higher median. And then the second statement will be, because her semi-interquartile range was a lot higher, it means that her ticket sales were more spread out. So I'm just going to say, and her ticket sales were more varied. And I'm going to squeeze it in here. And the reason they are more varied was because of the higher semi-interquartile range. You don't specifically have to write that bit in, but I don't have really room to do it either. So that is the statement for that bit. So very like standard deviation, one about the median, one about the spread. And remember, median is a type of average, range is a type of average, mode is a type of average. But we get that stuck on thinking that average means your mean all the time. Okay, our next question, just from looking at it, I know it's a Trig question, so let's see what we've got. So we've got the distances of 7 and 11 and 86, and it wants the distance between B and C, right? This is a dream question because we're all good at these ones. This is a cosy corner. My wee trick though is I draw a stick man and I say, if you can put your head on the angle and you can wave both your arms out to 2 sides, then you can do cosine rule. A lot of people just call it cosy corners, 2 sides and angle in between. As long as you recognise it, it's this one. It's the one that goes a squared equals b squared plus c squared. It's the one that starts looking a bit like Pythagoras. Take away 2bc cos A. And then you substitute in those numbers, so you've got 7 squared plus 11 squared. Doesn't matter which way round they go. Take away 2 times 7 times 11 times cos of 86. Type that all in one go in your calculator, okay? And you get this number here, you get 159.2575 and so on. Remember, that's just what a squared is, so you still have to square root that number. So square root of that. And I'm just going to leave it on my calculator screen and press shift, I'm going to press square root answer. And that gives me 12.3 12.619, and it hasn't mentioned rounding, so I'm just going to round it to 2 decimal places, so 12.62 kilometres to 2 decimal places. And as I said, lovely 3 marks if you recognise the question, 1 for your answer, 1 for getting to there, 1 for your substitution. Okay, so we're now on to question 13. It's given as a function and it says it can be written in this form to find a and b. Now that form there, you should hopefully recognise is just completing the square. So we're going to start with the function x squared plus 14x minus 3. To complete the square, you do x plus half of the 14 is 7, all squared. 7 squared is 49, so you take away 49 and then you include the number you had, which was minus 3. Now that then gives you, when you tidy it up, minus 52. Okay, now they had an a where our 7 is, so a is 7, and where b is, we've got minus 52, so b is minus 52. Okay, and that's part A all done. Part B wants us to sketch this. So basically, once it's in completed the square form, means you can read off your turning point. So your turning point is plus 7 means it's going to negative 7. It's always the opposite of what you think. So your turning point is along to negative 7 and down to 52. And it's there's no negative in front of the bracket, so it's a smiley face. So I'm just going to do a wee sketch just now to show you what I've got so far. So I've got a smiley face at minus 7 minus 52, which will be somewhere over here. So there's my turning point, minus 7 minus 52. Okay, and then the other thing it says intersects, which the graph intersects the y-axis. Y-axis is when x is 0. Anything on the y-axis has a coordinate of 0. And if you go back to your original equation, turn all these to zeros. So x is 0, you're only left with minus 3. So it cuts at minus 3. Now it's not drawn to scale, but my y-intercept is in a negative position. My turning point is in a negative position. So that would be perfectly acceptable for your 3 marks. Now your 3 marks for this one would be for the shape, knowing the turning point and putting it on your shape, and then for getting the minus 3. If you're not too sure of these, on my YouTube page I've got a whole video of practicing drawing these. If you want to look up Mrs McTaggart Maths sketching quadratics, this will be the completing the square form. There is one that's also sketching by factorising as well. We've got an area of a sector and we're told the area, we have to find the angle. So because we've been told the area, I'm going to start with the formula for area of a sector. So area of a sector is your angle over 360, and because it's area you stick pi r squared on the end, because area is pi r squared, arc is pi d. So we start with the formula, we put in what we know. So we know that our angle, we don't know, over 360 times pi times, now that diameter is 12, making your radius 6. So we know that that sum there equals 25, and all I did is I put the area bit to the right hand side because it's nicer. Now our goal, remember, is to get x on its own here. So we're going to undo all these other things around the x a bit at a time. The opposite of dividing by 360 is timesing by 360. So the first thing we're going to do is we're going to do 25 times 360. The opposite of timesing by pi times 6 squared is dividing by that. I'm just going to take that in one whole thing and make it pi times 6 squared. Now, if you've got your calculator on the fraction mode where it opens up like that and gives you a square over the square, I would tell you, just type that in as it appears. Do your top line on the top and your bottom line on the bottom. If you don't have that, when you're going to do the divide, you can put a bracket around the bottom or press equals after the top line. So for example, I'm doing 25 times 360 divided by bracket pi times 6 squared, closing my bracket, and it gives me 79.57. So I'm going to round that to 78 degrees, to the nearest degree. Okay, so remember, typing it in is the important bit. If you're using the fraction button, it's definitely the easiest. If you're not doing that, you have to put a bracket around the pi times 6 squared. Otherwise, the calculator will do the top line divided by pi and then times the whole thing by 6 squared, which is wrong. Also, look at the 78. It kind of matches the picture. That looks acceptable to me. Although they're not drawn to scale, they would never give you an obtuse diagram and you get an acute answer, and vice versa. Okay, so we're getting towards the end now. We have a volume question worth 5 marks. So what we've got is we've got 2 identical cones, right? So that's something to be aware of. These are identical, each with a small bit removed. And we have to find the volume of this sand timer. Right, so what I'm going to do is, if we can just ignore this whole bottom bit just now and just focus on this diagram. What we've got is we've got a big cone with a radius of 7. Okay, so a radius of 7. I'm just going to put that in a bit better. And the height of this cone would have been half of 26. Oh no, it's not. Oh, right, so it would have been 13, right, so from here to here is 13, plus this extra one, so it would have a height of 14. So that's a big cone. And then what we've got at the bottom is with a wee tiny cone with a height of 1 and a radius of 0.5. And then that's been subtracted. And then whatever that shape is, I've got 2 of them. So there's an awful lot going on this one. So what we have to do is we have to do big cone, wee cone, subtract them, and then whatever our answer is, we double it, because big cone, wee cone gives us this shape here that I'm just going to kind of highlight in a different colour. So big cone, wee cone would give us this shape here. Okay, and then obviously we've got 2 of them upside down, so that's what we're finding. So let's do the big cone first of all. So a cone is 1/3 pi r squared, so the big one is 1/3 times pi times a radius of 7 times a height of 14. Okay, remember these are on your formula sheet. The little one is 1/3 times pi times a radius of 0.5 and a height of 1. I'm going to go work both of them out. So that's the 2 answers I got. It's worth noting I've done them to 2 decimal places. I wouldn't round them any lower than that, otherwise you'll get penalised for rounding too prematurely. So there's the 2 areas. So the top half of the shape will be the 228.67, take away the 0.26, which is 228.41. And then the bottom will be the same. That'll be 228.41. So our total volume will be that doubled, which is 456.82 cubic centimetres. Okay, now I actually think this is probably worth a bit more than 5 marks, but there's definitely one for our final answer. There's one for each of our substitutions, so there's 3 marks. There's a mark for knowing to, there'll be a mark for your method, which is knowing to subtract and then double. So there'll be a mark for in there somewhere, okay? So, and there's lots of places to go wrong in this one, but again, lots of places to pick up marks for method and substituting into formulas correctly. So most people should be able to get at least 3 marks in that question, hopefully. Okay, brings us to a bit more of trigonometry. So we've got a transmitter and it tells us that this is exactly east, so that tells us that this is a right angle, okay? So that's a right angle there from O to T to D. We have to calculate the exact distance from O to D. So that's just going to be Pythagoras. So O to D squared is going to be 13 squared plus 3 squared. Which is 178. And then that would leave you as the square root of 178. Now, that is the exact distance, okay? So I'm going to leave it as that. And I think that's what it's wanting to do by exact. So we're going to use that in part B, because there's O to D mentioned again. So there's our square root of 178. We're told a lifeboat is on patrol at point L, 15 kilometres away on a bearing of 97. So that means this angle in here is 97. We have to use this information to calculate the distance between the lifeboat on patrol and the boat in distress. So the boat in distress is point D and the lifeboat is there. So this is what we have to find. Now we've got our two sides. Do we have anything else? I'm trying to think of how we can get an angle within this triangle, and the only thing I can see is, well, we've already kind of used this triangle here, O to D, and we knew this from up part here was 13 and C. If I knew this angle, then I could get the angle in my triangle. So if I go back to this triangle up here, if I get that angle that I'm colouring in blue, I can either use SOHCAHTOA or I can use Cosine Rule to get that angle. And then that would allow me to get the angle within the triangle by doing 180 with the whole straight line north to south. So this angle up here, this would be my opposite, my hypotenuse adjacent. This angle would be tan of x is 3 over 13. And then I'll do a shift tan of 3 over 13, which is 13 degrees. So if this is 13 degrees, 13 plus 97 is 110. So the angle in my triangle is 70. Right, so from there, I know my angle two sides in between. It's going to be cosine rule again. So it's going to be x squared equals 15 squared plus the square root of 178 all squared, which will just cancel out. Take away 2 times 15 times root 178 times cos of 70. And that gives me 266.106. I then square root that, and it gives me an answer of 16.31 to 2 decimal places. So that is the distance in kilometres between the two boats. Now, that was an awful lot there, I felt, for 4 marks. And I think it would be really tricky to try and get that angle of 70. We might not always spot that it comes back to part A. So if I have a look at the marking, part A, you would have a mark for knowing to use Pythagoras and doing it correctly. Part B, you would have a mark for finding out the 70 degrees, your substitution in there for your calculating it there. And then the 4th mark is either for the 266 or getting the angle of 13. I'm thinking it will be for the 266 if we follow normal marking rules. So yeah, that one was a bit tricky, but if in doubt, right, and you're looking at this question and thinking, if only I knew that angle, that 70, I could do the rest, make up that angle, make it up and say, oh, it looks about 60 to me. If you had said that this angle here of 70, that I'm just going to circle, if you had said that was 60 somewhere on your page and then substituted it in and done all the cosine rule, you would have still got most of the marks. So remember in trigonometry, if you think you need an angle and you don't have it, write down let angle DOL equals 60 degrees and then continue from there. The marker will follow through your working, so even if you couldn't start it, you knew the right method to use from there. So, and that is the end. I hope this has been useful. I hope it's been helpful. There's some tricky questions in there, but thanks very much.